To find the wattage of a wire wound variable resistor, there are several methods that can be used. Firstly, contacting the manufacturer is often the most direct approach. In this case, reach out to OMITE directly and provide them with the information that is available on the label of the resistor. This includes the model number 568, the resistance value of 250 ohms, and any other markings such as the characters XX46. The manufacturer may be able to provide you with the wattage rating or a datasheet containing this information. Secondly, the characters XX46 on the label may represent a resistor code. It is recommended to use a resistor code calculator to decode this value, which may help in identifying the wattage rating of the resistor. These calculators can be found online and can assist in deciphering the code to determine the resistor specifications. Thirdly, if other methods are not successful, measuring the resistance and estimating the wattage can be a viable option. Use a multimeter to measure the resistance of the resistor at different positions. Then calculate the maximum possible power dissipation using the formula P equals V squared divided by R, where P is the power in watts, V is the voltage across the resistor, and R is the resistance in ohms. Estimate the wattage based on the maximum power dissipation. Keep in mind that this method provides an estimate, and it's important to consider safety margins. Fourthly, another approach is to check similar resistors. Search for similar wire wound variable resistors from OMITE that have the same or close resistance values. Check the datasheets or specifications of those resistors to find the wattage rating. This can provide a reasonable estimate of the wattage rating for the resistor in question. It is important to note that the wattage rating of a resistor is typically not marked on the component itself, but is usually specified in the datasheet or by the manufacturer. The wattage of a resistor is crucial to ensure it can handle the power it will be dissipating in the circuit without overheating or failing. It is generally acceptable to use a slightly larger wattage rheostat for convenience, as long as it has the same or lower resistance value. This ensures that the circuit will function correctly and the rheostat will be able to handle the power requirements. Using a larger wattage resistor will not negatively affect the circuit, but using a lower wattage resistor could cause it to overheat and fail. When replacing a resistor, always ensure that the replacement has a wattage rating equal to or greater than the original to ensure safe and reliable operation. If the original resistor had a ceramic tube that broke when it blew, this indicates that the resistor was likely subjected to excessive power dissipation. Choosing a higher wattage replacement can help prevent this issue from recurring. When calculating power dissipation, it is essential to use accurate values for voltage and resistance. In AC circuits, the voltage should be the root mean square or RMS voltage. In DC circuits, the voltage is simply the direct current voltage. The resistance should be measured accurately using a multimeter, ensuring that the resistor is disconnected from the circuit to avoid any interference from other components. Consider that resistors in electrical systems must adhere to standards and best practices, particularly those outlined in the National Electrical Code or NEC. Although NEC is mentioned, remember that specific sections and requirements evolve with each edition. The NEC provides guidelines for the safe installation and operation of electrical components. When choosing a replacement resistor, it is important to select one that is rated for the appropriate environmental conditions. This includes temperature, humidity, and altitude. Resistors that are exposed to high temperatures or humidity may require a higher wattage rating to ensure reliable operation. Additionally, resistors used in high-altitude environments may need to be derated to account for the lower air pressure and reduced cooling efficiency. The physical size of the resistor can sometimes provide an indication of its wattage rating. Larger resistors typically have higher wattage ratings than smaller resistors. However, this is not always the case, and it is important to verify the wattage rating using the methods described earlier. When installing the replacement resistor, ensure that it is properly mounted and cooled. This may involve using a heatsink or other cooling device to dissipate heat. The resistor should also be positioned away from other heat-sensitive components to prevent them from overheating. When working with electrical circuits, always take appropriate safety precautions. This includes disconnecting the power supply before working on the circuit, wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. It is also important to have a thorough understanding of the circuit and the function of each component before making any changes. In summary, finding the wattage of a wire wound variable resistor involves several methods. Firstly, contacting the manufacturer. Secondly, using a resistor code calculator. Thirdly, measuring resistance and estimating wattage. And fourthly, checking similar resistors. Choosing a replacement with an equal or higher wattage rating is crucial for safe and reliable operation, and always prioritize safety when working with electrical circuits. Keep in mind that the information provided on the resistor's label, such as resistance and any specific codes, is essential for identifying its wattage rating. These details, combined with the methods discussed, should help in finding a suitable replacement for the damaged resistor. Also, remember to consider the environmental conditions in which the resistor will be operating and choose a resistor with an appropriate wattage rating for those conditions. Furthermore, proper mounting and cooling techniques should be employed to ensure that the resistor operates within its safe temperature range. Taking these factors into account will contribute to the overall reliability and longevity of the electrical circuit. If the resistor is part of a larger assembly or device, consulting the device's documentation or contacting the device manufacturer can also provide valuable information about the resistor's specifications and recommended replacements. Consider that some resistors may have specialized characteristics or requirements that are not immediately apparent. If the resistor is used in a critical application, it may be necessary to consult with an experienced electronics technician or engineer to ensure that the replacement resistor is suitable for the application. Also, be sure to document the changes made to the circuit, including the specifications of the replacement resistor and any modifications that were made to the circuit. This documentation can be helpful for future troubleshooting or maintenance. When measuring the resistance of the resistor, ensure that the multimeter is set to the appropriate range. If the resistance is unknown, start with the highest range and gradually decrease it until an accurate reading is obtained. Also, be aware that some multimeters may have a small amount of internal resistance, which can affect the accuracy of the measurement. It is generally acceptable to subtract the multimeter's internal resistance from the measured value to obtain a more accurate result. When calculating the power dissipation, it is important to use consistent units. If the voltage is in volts and the resistance is in ohms, the power will be in watts. If the voltage is in millivolts and the resistance is in kiloohms, the power will be in microwatts. Ensure that all values are converted to the same units before performing the calculation. When searching for similar resistors, pay attention to the tolerance rating. The tolerance rating indicates the accuracy of the resistor's resistance value. A resistor with a lower tolerance rating will have a more accurate resistance value than a resistor with a higher tolerance rating. Choose a replacement resistor with a tolerance rating that is equal to or lower than the original resistor. Also, be aware that some resistors may have a temperature coefficient of resistance or TCR. The TCR indicates how much the resistor's resistance value changes with temperature. A resistor with a lower TCR will have a more stable resistance value over a wider temperature range. Choose a replacement resistor with a TCR that is appropriate for the application. In addition to wire wound resistors, there are other types of resistors, such as carbon film resistors, metal film resistors, and surface mount resistors. Each type of resistor has its own advantages and disadvantages in terms of cost, accuracy, temperature stability, and power handling capability. Choose a replacement resistor that is appropriate for the application. When replacing a resistor, ensure that the replacement resistor is properly oriented. Some resistors are polarized, meaning that they must be installed in a specific direction. If a polarized resistor is installed backwards, it may not function correctly or may even be damaged. Check the resistor's datasheet to determine its proper orientation. Also, be aware that some resistors are sensitive to static electricity. When handling static-sensitive resistors, take precautions to avoid static discharge, such as wearing an anti-static wrist strap and working on a static dissipative surface. Static electricity can damage or destroy sensitive electronic components. Furthermore, be aware that some resistors may contain hazardous materials such as lead. When disposing of old resistors, follow proper disposal procedures to avoid environmental contamination. Do not dispose of resistors in the regular trash. In addition, consider that some resistors may be coated with a protective material such as epoxy or silicone. This coating helps to protect the resistor from moisture, dust, and other contaminants. When replacing a coated resistor, choose a replacement resistor that has a similar coating. Remember, the NEC Section 310.15 provides guidance on opacity of conductors and should be consulted when dealing with circuits involving resistors and conductors. Also note that the NEC Section 110.3b covers the installation and use of listed or labeled equipment, which is relevant to resistors that have specific listings or labels. Finally, always refer to the latest edition of the NEC and consult with a qualified electrician or electrical engineer for specific requirements and interpretations. These details should provide a comprehensive understanding of how to find a suitable replacement for a wire wound variable resistor.